Think about this. Almost every time you step onto a commercial plane, chances are it was made by one of just two companies, Airbus or Boeing.
That's right. For decades, really, they've basically had the market cornered. It's a classic duopoly.
And that's exactly what we're diving into today. One of you sent us a great comparison, and, well, our goal is to break down the main differences between these two giants of the sky.
Yeah, we're aiming to cut through, the really complex engineering talk.
Right.
We want to focus on what really sets them apart. There are different ways of thinking about design, specific features you might notice, the tech they use, even how the companies themselves operate.
So this should give you a kind of shortcut to understanding what makes an Airbus and a Boeing a Boeing.
Exactly. A clear, concise look.
Okay, let's jump right in. A good starting point seems to be their core philosophy. How they approach designing the plane's controls. Is it about the pilot or more about the computer?
That's a fundamental one, yeah. Boeing traditionally has had this pilot-centric approach.
Pilot-centric.
Meaning the pilot is the ultimate authority. That's their line. The pilot is the final authority. Even with their modern fly-by-wire systems, where computers translate the pilot's inputs, Boeing designs it so pilots can override the computer's suggested limits if they absolutely feel it's necessary, say in a really extreme, unusual situation to recover the aircraft.
So the final say rests with the human in the cockpit, even if it means pushing the boundaries a bit.
Yeah.
That puts a lot of trust in pilot judgment.
It does. Now, Airbus, they approach it differently, more computer-centric, you could say.
Okay, so what does that look like in practice?
Airbus builds in what they call hard limits within their flight control software, especially in normal flight modes.
Hard limit.
Yeah, the automation is designed to actively prevent the pilot from making inputs that would take the plane outside of its safe operating envelope.
Like what, for example?
Like preventing a stall where the wings lose lift or banking the plane too steeply. The idea is that the computer acts as a safety net against potential pilot error, which historically has been a factor in accidents.
So it's kind of a fundamental disagreement, maybe, about where the biggest risk lies. Human error versus those rare situations where the pilot needs total control.
You could definitely see it that way. It shapes everything else.
Can you give us a quick real-world example of how this difference might play out?
Okay. Imagine a situation where a pilot needs to pull up very sharply. An Airbus, in its normal operating mode, might simply refuse to exceed a certain pitch angle, preventing a potential stall no matter how hard the pilot pulls the stick.
The computer says no.
Pretty much. A Boeing, in a similar situation, would likely provide strong warnings, maybe make the controls feel heavier, resisting the input, but it would still allow the pilot to push through that resistance and exceed the normal limit if they keep insisting.
Got it. So Airbus draws a line, while Boeing warns you, but ultimately lets the pilot cross it. That's clear. Now, another difference seems to be about commonality versus making each plane unique.
Yes, absolutely. Airbus puts a huge emphasis on commonality across its different aircraft families, meaning they try hard to make the cockpits and the way the planes handle feel very similar, whether you're talking about a smaller A320 or the giant A380.
So pilots can switch between models more easily.
Exactly. It simplifies training. For instance, pilots can often get a common type rating to fly both the A330 and A340 with minimal extra training. That saves airlines a lot of time and money. Mechanics benefit, too, from similar systems.
Makes sense from a business perspective for the airlines, lower costs, more flexibility. What about Boeing's approach, then? Is it different?
Boeing tends to focus more on optimizing each aircraft model specifically for its intended role.
So less emphasis on making them all feel the same.
Generally, yes. While there's certainly commonality within a family, like the 737 lineage, or between the 757 and 767, which had a common rating. If you compare across different Boeing families, say a 737 pilot moving to a 787, there's typically more variation in the cockpit layout and systems.
More training required then, usually.
Usually, yes. Boeing's philosophy allows them to tailor each design very specifically, but it means less interchangeability for pilots compared to Airbus.
Okay, so Airbus, keep things similar. Boeing, optimize each one individually. Let's move on to engineering priorities. How they adopt new tech. Do they differ there too?
Oh, definitely. Airbus has often positioned itself as an early adopter, trying to leapfrog existing designs.
Examples?
Well, the big one was the A320 back in '88, the first commercial airliner with full digital fly-by-wire controls. And more recently, their extensive use of lightweight composite materials on the A350. They seem keen to integrate the latest stuff.
So pushing the technological envelope is part of their brand.
It seems to be a key part, yes. Boeing, being the older, more established player with a huge existing fleet, well, they've often taken a more evolutionary path.
Build on what works.
Kind of, making incremental improvements, refining proven designs. They also tend to retain certain elements for familiarity, like keeping the traditional control yoke instead of switching to a sidestick like Airbus.
So, Airbus the innovator, Boeing the refiner. Maybe too simple, but gives an idea. And you mentioned they made some big bets based on different visions of the future.
Right. Two perfect examples. Airbus went all in on the A380 Super Jumbo.
The double-decker.
Yeah, betting that airlines would need massive planes to connect major hubs. Boeing, around the same time, put its chips on the 787 Dreamliner.
Which was different how?
Smaller, but super fuel efficient, designed for long-haul routes between potentially smaller cities, point-to-point travel, not just hub-to-hub.
And those bets played out differently, didn't they?
They really did. The market for planes as large as the A380 just didn't materialize as strongly as Airbus hoped, and they eventually stopped production.
Ouch.
The 787, though, despite some early technical hiccups, has been a major success. It showed that the point-to-point model was where a lot of the growth was.
But you also said both philosophies have their merits.
Absolutely. Boeing's pilot-in-command focus could be crucial in unforeseen emergencies. Airbus's automated protections aim to prevent common errors, which is arguably where most incidents originate.
So not strictly better or worse, just different trade-offs. And are they maybe learning from each other now?
It certainly seems that way. Newer Boeings, like the 787, incorporate much more automation than older models. And newer Airbus designs, like the A350, have introduced things like active side sticks that provide some tactile feedback, moving closer to Boeing's feel.
Interesting. So a gradual convergence, maybe?
A bit, yeah.
Yeah.
While the core philosophies remain distinct, the lines are blurring slightly at the edges.
Okay, we've got the philosophies down. Now, for the fun part for plane spotters. How can you tell them apart just by looking? Are there easy visual clues?
There definitely are. Aviation enthusiasts love picking these out. One of the quickest giveaways is often the nose shape.
The nose.
Yeah. Airbus noses tend to be rounder, more bulbous. Think of the A320's kind of dolphin nose. Boeing noses are typically pointier, sharper, like on the 737.
Rounder Airbus, sharper Boeing.
Right.
Got it. Are there exceptions?
Well, yeah. The newer wide bodies, the A350 and the 787, both have sleeker, more pointed Roman nose profiles. But even then, you look at other things.
Like what? What else stands out?
The cockpit windows are a big one. Classic Airbus designs like the A320, A330, A340 have this distinctive shape on the rearmost side window. It looks like a corner is cut off, making the top edge slant down.
The drooped eyebrow.
That's the one. Boeing windows are generally more angular, more squared off, though some very old Boeings did have little eyebrow windows above the main ones, but you don't see those much anymore.
Okay, so notched window suggests Airbus. What else?
Look for the masked cockpit on newer Airbuses, like the A350 and some A320neos. They paint a black frame around all the cockpit windows.
Oh, yeah, like sunglasses.
Exactly. Makes it look like one smooth, dark panel. Some call it the raccoon mask. That's a strong indicator of a modern Airbus. Boeing doesn't usually do that stylistically unless it's part of a specific airline's paint scheme.
Round nose, notched window, maybe a mask. Good Airbus clues. What about wings? Anything different there?
Wingtips are a classic spotter's clue, though they've evolved. Older Airbus planes often had simple vertical fences sticking up and down.
Right.
Newer ones have sharklets, which are those tall, curved winglets sweeping upwards. Boeing uses various types of blended winglets that curve up smoothly, or raked wingtips, which are longer and sweep back more gently, like on the 787 and the upcoming 777X.
Any plane without winglets.
Interestingly, the original Boeing 777 models have clean, tapered wingtips, no winglets at all. Also, wing flex can be a subtle clue.
How much they bend up.
Yeah. Composite wings, like on the 787, tend to flex upwards quite dramatically in flight. The A350's composite wings also flex, maybe a bit differently. Aluminum wings on older designs flex less.
Okay, wingtips and wing flex. What about the engines?
Another good visual cue. Look at the back edge of the engine casing, the nacelle. Newer Boeing 787, 737MX, 777X often have serrated edges, like zigzags.
Chevron.
Those are the chevrons. They help reduce noise. Airbus engines typically have smooth, circular, trailing edges. They have noise reduction tech too, but usually not the visible chevrons.
Anything else about engines?
Yes. Look closely at a Boeing 737 engine from the side or front. Because the plane sits low, the bottom of the engine nacelle is often flattened.
The full amount.
Yeah, to give enough ground clearance, it's nicknamed the hamster pouch shape. Airbus A320s sit higher, so their engines are perfectly round underneath.
Huh, hamster pouch. We'll forget that. So a flat-bottomed engine almost guarantees a 737.
Pretty much, yeah. On a single-aisle jet, it's a dead giveaway.
Okay. Any other quick visual tips?
Maybe the tail shape can look subtly different sometimes, tail-fin proportions. Passenger window shapes can vary slightly, maybe more rounded squares on Airbus, sometimes more rectangular on Boeing.
Subtle ones.
And the really obvious one for the giants, the Airbus A380 is the only one with 2 full-length passenger decks, 2 rows of windows all the way back. The Boeing 747 has that distinctive partial upper deck, the hump at the front.
So nose, windows, wingtips, engines, overall shape. Plenty to look for. Great. Now, let's imagine we're inside the cockpit. What are the big differences a pilot sees or feels?
The absolute most striking difference is the primary flight control.
How they steer the plane.
Exactly. Boeing uses the traditional central control yoke. Looks like a steering wheel right in front of each pilot.
Over there.
Airbus, since the A320, uses a side stick controller. It's like a small joystick mounted on the outboard side of each pilot seat.
To the side. Why?
Well, it frees up space directly in front of the pilot. Airbus cockpits often have a fold-out tray table there, useful for paperwork or meals. The side stick is operated with one hand.
A yoke versus a side stick. That must feel really different to fly.
Hugely different. And it affects more than just feel. Boeing yokes are typically physically or electronically linked.
Meaning?
If one pilot moves their yoke, the other pilot's yoke moves identically. They can see and feel exactly what the other person is doing with the primary controls. Instant feedback.
Okay. And the Airbus side sticks.
Traditionally, they are not interconnected like that. One pilot's input on their side stick doesn't cause the other stick to move.
No physical feedback between them.
Not directly. Pilots rely on watching the instruments and clear communication to know what inputs are being made. This lack of tactile feedback was a factor discussed in the Air France 447 investigation, for example.
Interesting. So pilots need to be more reliant on instruments and verbal calls in an Airbus.
You could say that, although newer Airbuses like the A350 are introducing active side sticks that can electronically mimic some feedback between the two. But the fundamental principle of the computer interpreting the inputs remains.
What about keeping the plane trimmed, like flying straight and level?
Another difference. Boeing's system often requires pilots to make small, continuous adjustments using trim controls as speed or configuration changes, providing that constant feel. Airbus flight control laws largely automate the trimming process. The computer handles it.
So less hands-on trimming for the Airbus pilot.
Much less in normal flight, the side stick usually stays centered unless making a command.
Okay, yoke versus side stick, linked versus independent, manual versus auto trim. What about the throttles, the power levers?
Another classic difference. In an Airbus, when the auto thrust system is engaged, the system managing engine power automatically. The thrust levers typically stay in a fixed position, a detent, like CL, for climb power. The computer adjusts the actual engine thrust, but the levers themselves don't move. Pilots monitor the power setting on the engine displays.
The levers stay still, but the power changes.
Correct. Boeing's equivalent system, the auto throttle, physically moves the thrust levers back and forth as it commands power changes.
So Boeing pilots actually see the throttles moving.
Yes. It provides a very direct visual and sometimes tactile cue of what the automation is doing with the engine power. Airbus pilots rely purely on the digital readouts.
That must feel quite different for pilots switching between types.
It really does. Pilots often comment on it, finding it odd that the levers don't move in an Airbus, or appreciating the moving throttles in a Boeing as a familiar feedback mechanism.
Seems like a lot of differences in just how the pilot interacts with the plane. What about the information displays and warning systems?
Airbus uses a system called ECAM, Electronic Centralized Aircraft Monitor.
Okay.
It displays engine information and system status, and crucially, when a problem occurs, it often automatically displays the relevant checklist or procedure for the pilots to follow on screen.
Kind of guides them through it.
To a large extent, yes. Boeing uses a similar system called a KISIS Engine Indicating and Crew Alerting System. It also provides warnings and system info. But Boeing's philosophy often relies more on the pilots recalling initial memory items for certain critical failures and then referring to a physical or electronic quick reference handbook, QRH, for the full procedure.
So Airbus automation is more proactive in showing the procedure, while Boeing keeps the pilot maybe a bit more involved in the diagnosis and recall.
That's a fair way to put it. It aligns with their broader philosophies. Visually, too, modern Airbus cockpits tend towards a very clean digital look with large integrated displays.
Fewer knobs and dials.
Generally, yes, especially on the newest models with touchscreens. Boeing cockpits, while also highly digital now, like the 787, sometimes retain a bit more of a traditional layout, maybe looking slightly busier to some eyes, especially older models.
Okay, that gives a good picture of the flight deck differences. Let's dig deeper into the technology, starting with that fly-by-wire system. You said Airbus was the pioneer.
They really were for commercial jets. The A320 in 1988 was revolutionary for bringing full digital fly-by-wire to a narrow-body airliner.
And just to recap, fly-by-wire means
Instead of physical cables and rods connecting the pilot's controls directly to the wings and tail surfaces, the pilot's inputs go to computers as electronic signals. The computers then command actuators to move the surfaces.
got it. So Airbus went all in from the A320 onward.
Yes, all subsequent Airbus designs have been fly-by-wire from the outset. Boeing was more gradual. The 737 still uses conventional controls for the main surfaces, though with augmentation. Their first full fly-by-wire airliner was the 777 in 1995.
Nearly a decade later. And even then, they kept the yoke and aimed for a more traditional feel.
Exactly. They designed their fly-by-wire to mimic the feedback and handling qualities pilots were used to.
And we touched on the hard versus soft limits. Can you expand on that?
Sure. Airbus's hard limits mean that in normal law, the flight control computers will prevent the pilot from exceeding predefined safety parameters like maximum angle of attack to prevent stalls, maximum bank angle, or maximum G-load. The controls simply won't allow it.
The computer enforces the limits.
Agree. Boeing's soft limits on the 777 and 787 provide resistance. As the pilot approaches a limit, the controls might get heavier, pushback.
A warning feel.
Yes, a tactile warning. But a determined pilot can push through that resistance and command the plane beyond the normal envelope if they exert enough force.
Why the difference? Safety implications.
Both argue their approach is safer. Airbus says preventing excursions from the safe envelope stops many potential loss of control accidents caused by pilot error or disorientation.
Makes sense.
Boeing argues that in truly extreme, unforeseen circumstances, maybe like a wind shear escape or avoiding a collision, the pilot needs the absolute final authority to maneuver the aircraft aggressively, even if it temporarily exceeds normal limits.
And real-world events have shown potential issues with both approaches.
Sadly, yes. As mentioned, the lack of sidestick feedback was a factor in the Air France 447 stall, and the tragic Boeing 737 MAX accidents highlighted dangers of complex automation, the MCS system, that pilots weren't fully aware of or couldn't easily counteract. Both companies continually learn and adapt based on these events.
It's complex. What about the feel? We talked about the trim.
Right. Because Boeing's fly-by-wire tries to replicate conventional handling, pilots often still need to make manual trim adjustments using switches, especially on the 777. They feel the forces changing through the yoke.
Because they get that tactile sense of the plane's balance.
Yes. Airbus's system, with its auto-trim function, eliminates most of that manual work. The plane stays trimmed automatically.
Easier for the pilot, perhaps.
Arguably, yes, it reduces workload, but it means the pilot relies more on instruments to understand the trim state rather than feeling it through the controls. It leads to that saying, Boeing pilots feel the aircraft, Airbus pilots fly the numbers.
That really crystallizes the difference in interaction. Okay, moving from controls to construction, materials. Boeing made a big splash with composites on the 787, right?
A huge splash.
Right.
The 787 Dreamliner, launched in the mid-2000s, was the first large commercial jet built primarily from carbon fiber reinforced plastic composites.
What parts?
The fuselage sections, the wings, about 50% of the aircraft by weight. This was groundbreaking.
And the benefits?
Big ones. Significant weight savings, leading to better fuel efficiency. Composites don't corrode like aluminum, reducing maintenance. And they allowed for a stronger structure that could handle higher cabin pressure and humidity.
Making it more comfortable for passengers.
Exactly. Less dry air, lower cabin altitude feel.
Did Airbus follow suit?
They did. Their competitor, the A350, also features extensive use of composites around 53% by weight, including the fuselage and wings. So Boeing pushed the boundary, and Airbus responded relatively quickly.
Any difference in how they use composites?
A subtle one in fuselage construction. Boeing pioneered building large single-piece composite fuselage barrels for the 787. Airbus stuck with a more conventional approach for the A350, assembling the fuselage from large composite panels. Both achieved similar results, though.
And composites weren't totally new, were they?
No, both had used them in smaller amounts before on tail sections, control surfaces, fairings, but the 787 and A350 represented a major step up to primary structures. Now composites are filtering down even to narrow bodies like the 737 MX tail cone and the A220 wing.
Interesting. You also mentioned the 787 was more electric. What's that about?
Another significant Boeing innovation on the 787. Traditionally, jet engines supply hot, high-pressure air bleed air tapped off the compressors,
What's that used for?
powering various systems: air conditioning, cabin pressurization, anti-icing, starting the engines, sometimes hydraulic pumps.
Okay.
And the 787.
Boeing designed the 787 to largely eliminate the need for bleed air for these main functions. Instead, the engines primarily drive powerful electric generators.
So electricity powers those systems instead.
Pretty much. Electric compressors for cabin air, electric anti-icing, electric engine starting. The goal was improved engine efficiency, not bleeding air helps, and potentially simpler maintenance.
A big shift. What did Airbus do on the A350?
Airbus decided to stick with a more conventional, proven bleed air architecture for the A350. They viewed it as less risky, more mature technology.
And how did that play out?
787's more electric systems did face some teething problems early on, particularly with battery technology. The A350 systems, being more traditional, were perhaps less troublesome initially. It highlights that engineering trade-off again: Boeing's bolder technological leap versus Airbus's more conservative, proven approach in this instance.
Fascinating. What about aerodynamics and fuel efficiency shaping the plane?
Well, both are constantly refining shapes for less drag. You see things like higher aspect ratio wings, longer and thinner, advanced winglet designs, efforts to maintain smooth laminar flow over surfaces. It's a continuous competition.
And engines. Does one company have better engines?
Not really, no. Both Airbus and Boeing source their engines from the big global manufacturers: General Electric, GE, Rolls-Royce, Pratt & Whitney, and the G-Safran joint venture CFM International.
So they use the same engine suppliers.
Often, yes. They select the best available engine technology for a given aircraft size and mission. For example, the A320neo offers choices between the CFM LEP-1A and the Pratt & Whitney geared turbofan, GTF. The competing 737X uses a specific version, the CFM LEP-1B. Efficiency is paramount for both.
Are there exclusive engine deals sometimes?
There are. The massive G9X engine is exclusive to the Boeing 777X. The Rolls-Royce Trent XWB is exclusive to the Airbus A350 family, but generally they're competing using the top engine tech available from third parties.
Any unique aerodynamic features? You mentioned something about the 777X wings.
Ah, yes, the folding wingtips on the 777X, that's unique.
Folding wingtips. Why?
To give it an incredibly long, efficient wingspan in flight, but then fold the tips upwards on the ground so it can fit into existing airport gates designed for smaller wingspans. It's a clever engineering solution by Boeing.
Has Airbus done anything like that?
Not folding wingtips, no. Their designs have generally fit existing infrastructure, but you could point to Airbus's earlier adoption of digital fly-by-wire, Sidesticks, and achieving fleet-wide capability for automatic landings in very low visibility, Category 3, as their pioneering aerodynamic and control system contributions.
So constant innovation on both sides, just in different areas sometimes. Let's shift now to the companies themselves. Tell us a bit about Airbus history, structure, strategy.
Okay, Airbus has a fascinating origin. It was formed in 1970 as a European consortium, a partnership between French, German, and later British and Spanish aerospace firms.
A deliberate effort to compete with America.
Absolutely. To challenge the dominance of Boeing, McDonnell Douglas, and Lockheed at the time. Their first product, the A300, was the world's first twin-engine wide-body jet, quite innovative.
And the A320 was their big breakthrough.
Huge. Launched in the late 80s with fly-by-wire, it became a massive seller and really established Airbus as a major player. From there, they expanded their family A330, A340 wide bodies, the A380 Super Jumbo Gamble, the A350, and more recently acquiring the C-Series program from Bombardier, now the A220, giving them a foothold in the smaller jet market.
Where are they based? And how are they organized?
Their main operational headquarters and final assembly lines are in Toulouse, France, but key manufacturing and engineering sites are spread across Europe, Hamburg in Germany, Broughton in UK, various sites in Spain. It reflects their multinational roots. The parent company is Airbus SE, registered in the Netherlands, with divisions for commercial aircraft, defense and space, and helicopters.
And government involvement.
Historically, yes. European governments provided significant launch aid loans for new aircraft development, which has been a long-running source of trade disputes with Boeing and the U.S., who argue it's unfair subsidy. That relationship is complex but undeniable. The culture is often seen as collaborative, pan-European.
How about their market strategy? How did they grow?
Initially, by finding niches, offering fuel efficiency, and leveraging technology like fly-by-wire. Their emphasis on family commonality became a huge selling point for airlines. They've also been known for aggressive sales tactics, sometimes using favorable export credit financing.
Any key strategic wins lately?
The A320neo family, beating Boeing to the market with new engine options, was massive. They've effectively capitalized on Boeing's recent struggles, particularly with the 737X grounding, to gain market share. They currently lead in the number of aircraft in service and have a larger order backlog.
I'm looking forward.
They're pushing into new segments like the extra-long-range, narrow-body market with the A321XLR, investing heavily in future tech like hydrogen propulsion, and localizing production with assembly lines in the U.S., Mobile, Alabama, and China, Tianjin, to be closer to key customers.
Okay, quite a story of challenging the incumbent. Now, Boeing. Older company, different background.
Much older. Founded by William Boeing in Seattle way back in 1916. Started with seaplanes, mail planes, military aircraft in the early days. Then they really defined the jet age for passengers with the 707 in the late 50s.
And then came the legendary lineup.
Exactly. The 727, the incredibly successful 737, the iconic 747 jumbo jet, the 767, the 777 777. They also absorbed their main U.S. rival, McDonnell Douglas, in 1997, inheriting their aircraft lines like the MD-80-90 and MD-11 for a time.
What are their main products now?
Currently producing the 737 MAX, the venerable 767, mostly as freighters and tankers now, the 777 and its successor, the 777X, and the 787 Dreamliner. Production of the 747 ended in 2022. And importantly, Boeing has a massive defense, space, and security division alongside its commercial airplanes.
Right. That's a big difference from Airbus's structure. Where is Boeing based now? They moved, right?
They did. Historically Seattle-centric, the corporate HQ moved to Chicago in 2001 and then again to Arlington, Virginia, just outside Washington, D.C., in 2022. This reflects the increasing importance of their government and defense business.
But the big factories are still near Seattle.
The main commercial aircraft plants are in Everett, wide bodies, and Renton 737 in Washington state. They also have the major 787 assembly line in North Charleston, South Carolina. Final assembly is primarily U.S.-based, though they have a vast global supply chain.
Any comments on their corporate culture? There's been discussion about changes after the McDonnell-Douglas merger.
Yes, analysts and insiders often point to a shift after the merger, suggesting a greater emphasis on financial performance and shareholder value, potentially sometimes at the expense of the traditional engineering focus. Some link this cultural shift to the issues surrounding the 737X development, though their underlying engineering capability remains world-class.
And Boeing's market strategy over the years.
As the longtime market leader, their strategy was often about defending their position, leveraging their large installed base, and responding to competitive threats. They had a broad product portfolio covering most airline needs and deep, long-standing relationships with many major carriers.
How did they react to Airbus's rise?
Initially, perhaps underestimated them. They famously downplayed the A380's market potential, which turned out to be correct. They often preferred evolving existing successful models like the multi-generational 737, offering continuity and lower transition costs for existing Boeing operators.
But they also created new market segments.
Absolutely. The 747 created the jumbo jet era. The 777 pioneered large twin-engine long-haul flight. The 787 pushed composites and efficiency. But they were forced to react more directly when the A320neo proved so popular, leading to the rushed development of the 737 MAX.
What about recent challenges and future plans?
The 737 MAX grounding and subsequent delivery halts, plus 787 production issues, have been major setbacks, costing market share. Their planned acquisition of Embraer's commercial jet business, aimed at competing in the smaller jet segment, collapsed. So their current focus is heavily on restoring confidence, stabilizing production, delivering their backlog, especially 737 MAX and 787, and successfully certifying and launching the 777X.
What new plane might they build next?
Most analysts expect Boeing will eventually launch a new mid-market aircraft, sometimes called the NMA or 797 concept, to compete directly with the successful Airbus A321neo variants, particularly the long-range XLR.
How do they typically sell their planes? What's their pitch?
Boeing often emphasizes aircraft durability, commonality within their own fleet types, their extensive global support network, and long-term value. They can also leverage their defense relationships to bundle commercial and military deals for certain governments or airlines. They have strong, often exclusive historical ties with many carriers.
So, a real contrast in history, structure, and recent fortunes. What's the overall market position now, and what's the outlook?
It's still fundamentally a duopoly. Market share fluctuates, but right now, they're roughly neck and neck in terms of the overall installed fleet, though, as we said, Airbus has pulled ahead in recent deliveries and has a larger order backlog, especially for narrow bodies.
And the rivalry drives innovation.
Constantly, you see direct responses. Boeing 787 spurred the development of the Airbus A350. Airbus's success with the A321LR and XLR is pushing Boeing towards that new mid-market plane. This competition benefits airlines and passengers, ultimately.
What about sustainability? That's huge now.
Both are investing heavily. Improving fuel efficiency of current and future models is priority one. Both are certifying their planes to run on 100% sustainable aviation fuels, SAFs. Looking further out, Airbus is making big public bets on hydrogen-powered aircraft, potentially by 2035. Boeing seems more focused on SAFs, electric propulsion research, and overall system efficiency improvements. Environmental pressure is a massive driver for both.
Near-term priorities.
For Airbus, capitalizing on the A320neo family's success and ramping up production. For Boeing, job one is restoring full confidence in the 737MX, smoothing out 787 production, and getting the 777X certified and delivered.
And the bigger planes. Wide-body competition.
That continues fiercely. It's Boeing's 777X and 787 families versus the Airbus A350 and A330neo families. The cargo market is also hot, with new freighter versions like the A350F and 777-8 freighter competing for orders.
Are both companies financially stable despite challenges?
Yes, despite supply chain issues, past crises, and economic headwinds, both remain financially massive, powerful companies. Boeing is working through its recovery plan, while Airbus is enjoying strong momentum currently.
Any final thoughts on their business models?
They differ slightly. Airbus benefits from a more integrated European aerospace strategy and historical state support. Boeing benefits greatly from its huge U.S. defense contracts and government relationships. Both are publicly traded global corporations, ultimately driven by customer demand and the intense need to outperform each other. Airbus is arguably more purely focused on commercial aviation success, while Boeing is more diversified with its defense and space interests.
Okay, that was a fantastic deep dive. Let's quickly sum up the key takeaways. What are the absolute core differences people should remember?
Well, I think it boils down to a few big things. First, that fundamental philosophy, Boeing's piloting command versus Airbus's computer-aided safety envelope.
Right, the hard versus soft limits.
Exactly. Second, Airbus's push for family commonality versus Boeing's tradition of model-specific optimization.
Easier training versus tailored design.
Third, those visual cues. We talked about the nose shape, cockpit windows like the eyebrow or mask, the wingtips, and definitely the 737's hamster pouch engine.
Can't forget the hamster pouch.
Inside, the yoke versus the side stick is the most obvious difference, plus how the auto-throttle, auto-thrust levers behave. Then there's the tech adoption Airbus early with fly-by-wire, Boeing leading the big composite push with the 787.
And finally, their company histories and strategies reflect their different origins. The European challenger versus the established American giant.
That covers the main highlights, I think.
Understanding all that really gives you a much clearer picture when you hear about these companies, or even just look out the airport window.
Absolutely. It demystifies things a bit, shows the different engineering paths taken to solve the same basic challenge. Safe, efficient air travel.
So here's a final thought to leave you with. This duopoly has lasted for decades, but things are always changing. With Airbus currently leading in orders, Boeing focused on recovery, and both facing pressure on sustainability. Will this balance of power hold?
That's the big question, isn't it? Could new technologies like radically different propulsion or maybe even new competitors from places like China eventually disrupt this two-horse race? Or will Airbus and Boeing continue to dominate the skies for the foreseeable future?
Definitely something to keep watching. The innovation and strategic moves from these two aerospace titans are far from over.